Okay. Yeah, good afternoon. My name is Henri Bertrand. I'm working for CERATIZIT, the tungsten carbide department. We are a part of the Plan Z group. We belong to the Plan Z group. What do you need to know about the difference between steel, hardened steel, or tungsten carbide? It's not really in detail because it's a combination also with the craft presentation. So I would show a little bit what is the process in the tungsten carbide production. Oh, it's not forwarding. Okay. Here, this was the beginning. Okay. The materials you can see, this is an overview between the wear resistance of the materials in combination to the toughness of the materials. As we all know, the most hard material is the diamond or the natural diamond, and also the PCD diamond. Then we have a phase between is the cubisch bohyminitride stadium with ceramics, cermets, and then we come to our material. It's a cemented carbide. As we can see, it's a big range that we can cover to toughness and also to wear resistance. And right down under, it's the steel part. As we can see, it's a high tough material, but related in the hardness, very low according to the other materials. So what are the advantages for tungsten carbide using compared to steel? So the wear resistance is much higher than in comparing to the steel parts, even to hardened steel. We always say where the hardness of hardened steel is limited, there we begin with our hardest. So it's always also measured in hardness figures. Also, at the high hardness, our materials are more resist, also even using in high temperatures. For example, for producing glass or steel production, which are working on high temperatures. We also have the right hardness in this. We have a huge application range, which I will show in the further slides. It's like cutting tools. We have wear parts division, woodworking, stoneworking, etc. So, and normally, we have a longer tool life, but that's depending on using it in which situation. As maybe not everybody knows, we are producing a product. It's with making by powder preparation. So it's we are using a granulate from APT. That's ammonium pyritungsten. That comes from the mines in China. Due kind of oxidation systems, we get different steps, and then we at the end we add a carbon into the tungsten powder, and then we get the tungsten carbide, and that is the base material. So it's a powder production material. We have the carbide granulate production. We can do it with the mixing mills. So we put it the granulate and some additives, and we mix it, and then we get ready to press powder. So for the maximum wear resistance of this powder, it's depending on which ingredients we are putting in. Also the grain size, we have different grain sizes. for the to making the hardness, and also to making the toughness for the material. And therefore, we have a lot of mixture in our portfolio. So as I said, we produce more than 100 carbide grades, and that's depending on the hardness, the toughness, and the break toughness. And there we can choose some combinations. How do we produce our products? We have some methods. It's die pressing. Die pressing is the most known. It's used also for the cutting tool inserts, also for saw tips. And that means we have a die, we put some powder in it, and we have the end product is ready and ready to get to the furniture where it will be sintered. We can do also our process by extrusion, and that means long rods or long products. Yeah, they can be done by an extrusion process. The most way to produce the wear part production is by the cold isostatic pressing. We use a press with an under and a top press, and then we make rods or blocks, and we press them as in preform, and there in that stage we can prepare our end size and end model of the products we have to use. Also a new method, very special, is the metal injection molding. It's powder injection, but we can, like making a plastic, yeah, we do the same way with tungsten carbide. After we have the form of the carbide product, yeah, we do the sintering part, and sintering means to get the product in the oven, and then the product will get the real hardness in the end stage. The sintering process is around 1300 to 1500 degrees in the oven, also under pressure, so we use the sinter hip ovens. And as you can see, after sintering, you have on the left, you have the preformed product, and after sintering, our end product will become 50% smaller, so 20 in sizes, and that's because of all the pressure is put in, and the binder from the tungsten carbide, yeah, is filling up all the holes, so therefore it's slinking. We can have some surface treatments, and that are normally very expensive treatments. So it's better to choose all kind of things we can make internal tolerances. Yeah, is doing it before in the preforms, and that means when you need a hole which is not so accurate, it's better to do it in the green phase, as we know. And the green phase is the pre-sintered part, because after sintering, the surface treatment, you can see what we are using is a very expensive method of the treatment, because it's grinding with diamond, polishing also with diamond. We can do the erosion part, which is also an expensive part. And then we have some extra, like sandblasting, galvanic coating. We can also do turning and milling, but in that case, it's also with diamond tools. I can go back. Can I play this video here? In red? I don't know how to. Yeah, I will come. And in the video, it's more visible how the production line is going. Oh, it's here. Okay. Yeah. finished. Okay. Ja, het is oké. Kijk.